Picture this. You are an ancient human. No shoes, no kitchen, no refrigerator humming in the background, no delivery app to rescue you when you cannot be bothered to cook. You woke up this morning, and before you could do anything else, before you could think, plan, or interact with a single other member of your group, you had to eat. And eating, in your world, meant spending the next several hours of your morning sitting and chewing. Not chewing something soft, not chewing something that had been tenderized or seasoned or prepared in any way. Chewing raw meat. Chewing tough, fibrous tubers pulled from the ground. Chewing hard fruits with thick skin and minimal sugar. Chewing things that modern humans would take one bite of and immediately reconsider their life choices. Chimpanzees, your distant evolutionary cousins, spend roughly 6 hours every single day doing exactly this. 6 hours, just chewing, because raw food is hard, fibrous, calorie-poor, and requires an enormous amount of mechanical effort from the jaw and an enormous amount of energy from the digestive system to extract anything useful from it. Raw food is, in almost every measurable way, a terrible deal for a large-brained primate with better things to do. And then one day, and nobody knows exactly when, and that uncertainty is one of the most fascinating puzzles in all of human science, something changed. Fire met food, and the world was never the same again. Today we are going all the way back to the moment that arguably did more to make us human than anything else in our entire evolutionary history. We are going to find out when ancient humans started cooking their food, how it probably happened, what it did to our bodies and our brains and our social lives, and why the answer to this question is not as simple or as settled as your high school history teacher probably made it sound. This is one of the most important things that ever happened to our species. Let's treat it that way. Let's start with what cooking actually does biologically, because understanding the mechanism is what makes everything else in this video make sense. When you apply heat to food, you are doing something remarkable at a chemical and structural level. You are breaking down the tough cell walls in plant material, making the nutrients inside dramatically more accessible to digestion. You are denaturing the proteins in meat, unraveling their tightly coiled structures into forms that digestive enzymes can attack far more efficiently. You are gelatinizing starches, converting them from a form that the human gut can barely process in raw form into a form that gets absorbed rapidly and completely. The net effect of all of this is that cooked food delivers significantly more usable calories per gram than the same food eaten raw, in some cases dramatically more. Cooked starchy tubers, things like wild yams and other underground storage organs that ancient humans relied on heavily, deliver nearly double the usable calories compared to the same tubers eaten raw. The difference isn't marginal, it's transformative. For a species that was trying to fuel an increasingly large and increasingly expensive brain, this difference was everything. Here is the central problem that cooking solved. The human brain is extraordinarily greedy. Brain tissue requires roughly 22 times the energy per unit mass of skeletal muscle tissue. A large brain is a metabolic extravagance. It consumes a disproportionate fraction of the body's total energy budget just to keep running. Bigger brains are generally advantageous for survival and social complexity, but they come at a caloric cost that the body has to cover somehow. For millions of years, the brains of our hominin ancestors were constrained by this energy budget. You can only grow a brain as large as your diet can power. And a raw food diet, however diverse and cleverly assembled, has a ceiling. Chimpanzees eating raw food all day long for 6 hours cannot extract enough calories to power a significantly larger brain than they already have. They are, in a very literal sense, eating as much as their food supply will allow and running their brains at maximum capacity on that budget. Ancient humans who learned to cook broke through that ceiling. They unlocked a dramatically larger caloric return from the same food sources, freed up energy that had previously been spent on digestion, and made available the fuel needed to grow and maintain a brain significantly larger than anything that had come before. Cooking didn't just change what ancient humans ate, it changed what ancient humans were. Now let's talk about the evidence. Because here is where the story gets genuinely complicated, and where one of the most important debates in paleoanthropology has been playing out for decades. The question of when ancient humans started cooking is not settled. There is significant disagreement between researchers, and the disagreement hinges on a fundamental tension between two types of evidence: biological evidence and archaeological evidence. And those two types of evidence point to dramatically different timelines. Let's start with the biological evidence, because it is the older and in some ways the more compelling of the two. Around 1.9 to 1.8 million years ago, something significant happened in the human fossil record. A new species appeared, Homo erectus. And Homo erectus looked dramatically different from the hominins that preceded it in ways that are almost impossible to explain without invoking a major change in diet. Homo erectus had a brain roughly 50% larger than its predecessor, Homo habilis. It had a significantly larger body overall, and it had dramatically smaller teeth, smaller jaws, and a smaller gut than anything in the hominin lineage before it. That combination, bigger brain, bigger body, smaller teeth, smaller gut, is deeply paradoxical if you're imagining an ancient human still eating raw food. Bigger bodies and bigger brains need more calories, not fewer. Smaller teeth and smaller guts are adaptations for processing softer, more easily digestible food. They are not adaptations you would expect to see in an animal that was still spending 6 hours a day chewing tough raw materials. Something had changed in the diet of Homo erectus that made smaller chewing apparatus and smaller digestive organs not just viable, but actually advantageous. Harvard biological anthropologist Richard Wrangham has argued, in a hypothesis that has been enormously influential and enormously controversial, that the something was cooking. His 2009 book, Catching Fire, lays out the case that cooking and control of fire were responsible for the evolution of Homo erectus, that the anatomical changes appearing 1.9 million years ago cannot be adequately explained by any other dietary shift, and that cooking is therefore at least 1.9 million years old as a human behavior. If Wrangham is right, ancient humans were cooking food nearly 2 million years ago. That is a staggering timeline. That puts the discovery of cooking well before the emergence of Homo sapiens, well before Neanderthals, well before anything we typically think of as recognizably human in a behavioral sense. Here is the problem. The archaeological evidence does not go back that far. Physical evidence of fire use, charred bones, ash deposits, hearth structures, burned plant material is genuinely difficult to find in the archaeological record before about 400,000 years ago. Reliable, well-documented evidence of controlled fire use gets firmer around 300,000 to 400,000 years ago at multiple sites across Africa and Europe. The oldest currently accepted direct evidence of cooking food specifically comes from a site in Israel, the Gesher Benot Yaakov archaeological site, where fish remains dating to approximately 780,000 years ago show clear signs of having been heated to cooking temperatures. 780,000 years. That sounds ancient, and it is. But it is also more than 1 million years younger than Wrangham's proposed cooking timeline based on the biological evidence from Homo erectus. That gap between roughly 1.9 million years based on anatomy and roughly 780,000 years based on the best currently available archaeological evidence is one of the central puzzles in this entire field. And there are two ways to interpret it. The first interpretation is that cooking is indeed old, possibly nearly 2 million years old, and that the archaeological evidence simply hasn't survived. Fire evidence is notoriously fragile. Ash disperses, charred material degrades. Exposed outdoor cooking sites from 2 million years ago would have been subjected to geological processes across an enormous stretch of time that could easily have destroyed any trace of fire use. The absence of evidence in this interpretation is not evidence of absence. We simply haven't found the fires yet. The second interpretation is that Wrangham's biological argument, while compelling, doesn't require cooking specifically. Some researchers argue that the anatomical changes in Homo erectus could be explained by a shift to eating more meat, particularly meat processed with stone tools, sliced and pounded to break down tough fibers before eating, combined with increased consumption of underground storage organs like tubers. Mechanical processing of food, in this view, could have produced softer, more calorie-dense meals without requiring fire at all. Cooking may have come later, building on a foundation of food processing that was already underway. The honest answer, sitting in the middle of this debate, is this. We don't know exactly when ancient humans first cooked food. The most widely accepted archaeological evidence puts it at roughly 780,000 years ago at minimum. The biological case suggests it could be much older, and the truth is probably somewhere in between. Early, tentative, inconsistent use of fire for cooking began well before 780,000 years ago, and the Gesher Benot Yaakov site has simply given us the earliest preserved evidence of a practice that was already established. Let's talk about how it probably happened, because the first time food was cooked was almost certainly not a deliberate experiment. It was almost certainly an accident. Ancient humans had been encountering fire long before they started controlling it. Wildfires swept across the African savanna regularly, regularly, ignited by lightning strikes, leaving behind landscapes of ash and charred vegetation, and, crucially, roasted animals that hadn't escaped in time. The smell of cooked meat drifting across a post-fire landscape was something ancient humans would have encountered repeatedly over millions of years. Animals cooked by wildfire are easier to eat than raw animals. The meat is softer, the bones are more accessible, the calories are more immediately available. An ancient human scavenging a wildfire's aftermath and eating cooked meat rather than raw meat would have experienced a direct, immediate benefit without needing to understand anything about why the food was different. It tasted better, required less chewing, and delivered more energy. That was enough. The transition from opportunistically eating food cooked by wildfires to deliberately using fire to cook food was probably gradual and happened over a very long time. Ancient humans first learned to keep fire alive, carrying embers from natural fires, maintaining them in protected locations, using them for warmth and protection before using them for cooking. The step from having a fire burning near your campsite to deliberately placing food near or over that fire is not a large conceptual leap, but it required both the regular presence of controlled fire and the accumulated observation that food placed near fire changed in ways that were beneficial. What probably happened at the Gesher Benot Yaakov site 780,000 years ago was not the invention of cooking. It was ancient humans who had already been cooking, inconsistently, experimentally in ways that left little archaeological trace, doing it deliberately enough and in a concentrated enough location that the evidence survived 780,000 years to be found by archaeologists using modern analytical tools. The actual first cooked meal is lost to time. It happened too long ago in conditions too impermanent for any physical evidence to survive. But it happened, and whoever ate it, whatever ancient human sat near a fire and tasted meat or tuber that heat had transformed, was eating something that would eventually change the trajectory of the entire human species. Here is something that almost never gets discussed when people talk about cooking and ancient humans, and it might be the most consequential consequence of cooking that nobody mentions. Time. Chimpanzees spend 6 hours a day chewing. Ancient humans eating raw food would have spent a comparable amount of time on the mechanical work of eating, finding food, processing it with their teeth, extracting what nutrition they could from it. That is 6 hours of every day consumed by the single activity of eating. Cooking changed that equation dramatically. Cooked food is soft. It requires far less chewing. It delivers more calories in less time. Ancient humans eating cooked food could extract the nutrition they needed from their diet in a fraction of the time required for raw food eating. Modern humans across all cultures studied spend less than 5% of their day on eating, a tiny fraction compared to our primate relatives. That freed time had to go somewhere, and where it went changed everything. Time freed from chewing became time available for tool making, for sitting and working stone into more refined and specialized shapes, a process that requires sustained concentration that is very hard to maintain when your jaw is constantly working. It became time available for social interaction, for the conversations, relationships, alliances, and conflicts that drove the development of language and social complexity. It became time available for exploring, for observing the environment, for the kind of open-ended attention to the world that generates new knowledge and new ideas. Some researchers have argued that cooking didn't just fuel the physical evolution of the human brain. It funded the behavioral evolution of human culture. It gave ancient humans the time budget to be more than just survival machines, to invest in relationships and skills and knowledge in ways that raw food eaters, constantly occupied with the work of extracting enough calories to survive, simply couldn't afford. The campfire in this interpretation was not just a cooking device. It was the original social technology. Ancient humans gathering around a fire to cook and eat together in the relative safety of firelight, with the day's food secured and the predators kept at a distance. That was the earliest version of something that would eventually become dinner parties, feasts, religious ceremonies, community gatherings, and every other form of communal eating that human societies have practiced across the entirety of recorded history. The campfire is where ancient humans learned to be social in the modern sense, where they told each other stories, where they processed the day's events together, where relationships were maintained and hierarchies were navigated, and knowledge was passed between generations. Every dinner table in the world today is a descendant of that campfire. That is not a metaphor. It is a direct cultural lineage going back hundreds of thousands of years. Let's talk about what cooking did to the human body over the long term, because the physical changes are remarkable and are written in our own anatomy in ways we carry around with us today. Ancient human ancestors before cooking had massive jaws. The muscles required to power those jaws were so large they attached to the top of the skull, requiring a bony ridge called a sagittal crest, the same ridge you see on the skull of a gorilla, to provide enough surface area for muscle attachment. Large jaw muscles pulling on the top of the skull constrains brain expansion. You cannot easily grow a larger brain case when powerful muscles are attached to the top and sides of it, pulling the bones inward. As ancient humans shifted to cooked food, those jaw muscles shrank. The sagittal crest disappeared. The skull shape changed. A rounder, more dome-like shape replaced the elongated, ridge-crested skull of earlier hominins. That rounder skull shape was not coincidental. It was the shape that a brain expanding in multiple directions simultaneously naturally produces. The constraint was lifted. The brain could grow outward and upward in ways that the muscled-down skulls of raw food eaters couldn't allow. The teeth shrank. Across the lineage leading to modern humans, tooth size reduced dramatically, particularly the large grinding molars needed to process tough, raw food. Ancient humans who were cooking their food didn't need the same dental machinery as those who weren't. Smaller teeth became not just acceptable, but advantageous, freeing up space in the jaw and reducing the metabolic investment required to grow and maintain large tooth structures. The gut shrank. The human digestive tract is notably short compared to other primates of similar body size. A longer gut is better at extracting nutrients from raw, tough, difficult to digest food. It gives the digestive system more time and more surface area to work on resistant materials. A shorter gut is a feature of an animal eating easily processed food. Cooking predigests food before it even enters the mouth. The heat does much of the chemical work that a long gut would otherwise need to do. Ancient humans who cooked could survive with shorter guts, and shorter guts freed up energy that could be redirected toward the brain. Every single one of these changes, rounder skull, smaller jaw muscles, smaller teeth, shorter gut, is visible in the fossil record at or around the time of Homo erectus. They are the physical signature of a diet transformed by fire. They are the marks that cooking left on our bodies permanently, carried forward across nearly 2 million years of human evolution into the body you are currently sitting in. You are, in a very real biological sense, a cooked food animal. Your body was built by cooking. It is optimized for cooked food in ways that make eating entirely raw food genuinely difficult for modern humans to sustain over the long term. Studies of people who attempt raw food diets consistently show that maintaining adequate caloric intake and body weight is challenging without cooking. The modern human gut is simply not equipped for the digestive demands of a fully raw diet in the way that our ancestors' guts once were. We cooked our way into existence, and then we evolved past the point of being able to comfortably go back. Here is the perspective that all of this research ultimately builds toward. Cooking is not a convenience. It is not a cultural nicety or a sign of civilization's refinement. It is not something that separates humans who have things figured out from the ones who don't. Cooking is what made us human, quite literally. The cascade of changes that fire and food together set in motion, more calories, larger brains, smaller guts, freed time, social campfires, cultural complexity, runs directly from that first accidental roasting of meat or tuber through every stage of human evolution right up to the present moment. The ancient human who first tasted cooked food didn't know what they were starting. They couldn't have known. They were responding to something immediate and practical. This is softer, this tastes better, this takes less work to eat. They were not planning the future of the species. They were just solving today's problem with today's tools. But the consequences of that accidental moment, of fire meeting food and an ancient human deciding this was better than what came before, rippled forward across nearly 2 million years of time into every human being who has ever lived, into every brain that has ever had a complex thought, into every conversation, story, and idea that has ever been shared around a fire. The campfire is where ancient humans became something more than survival demanded, and the meal cooked on it is where the human story really begins.